Hello everyone, today we'll talk about the problem largest local values in a matrix. We're given a matrix that's n by n, so it's a square. We want to return also a square matrix, but smaller by 2, so n minus 2 by n minus 2, such that at every position we have the maximum in the original grid of a 3 by 3 square centered on that position. And we have this n minus 2 by n minus 2 so that we don't have to worry about padding, about going outside of the bounds of our grid. So that this is only for positions that indeed do have all the 9 available spots to take the maximum from. So this is a simple implementation problem. You can implement it in whatever way you like. Today I'll show you a pretty, let's say, maybe interesting way. So if you are familiar with Python, then try to look at this code, maybe scoff a bit if you don't like it, but try to understand why it solves this problem. And now we'll go through it line by line. Of course, we get the size of the grid. We will generate our answer as a list comprehension. So we have a list within a list because that's what we have to return for every row and column in the appropriate range. So from 1 to n minus 1 not inclusive. So this is our n minus 2 by n minus 2. We have to return some maximum. And one way to implement all the elements that we have to take the maximum from is we first go through all the rows from the current row minus 1 to current row plus 2 non-inclusive, so all r minus 1, r plus 1. We take the grid at that row and also look at the columns, and in columns we have the same thing, so from minus 1 to plus 2 not inclusive. We can do that as a slice, so this column here is slice notation. If you're not familiar, then try to look for the slice notation. And then this will give us, because if you look at those parentheses, this is a generator expression. So it will generate first one list, then another list, then another list. So 3 lists. Now, if you want to take those lists and split them up to be, in a way, 3 separate variables, so that we can pass them to another function as 3 separate variables, we have this asterisk here. So essentially the asterisk is the unpacking operator. It will allow us to take a list, an iterable of things, and what we want to do is to create a longer one that includes all the 9 values and not, in a way, let's say a list of 3 lists. And one way to do that, to do this flattening operation, would be to use chain from iter tools. Chain, when it's given some collections, some iterables, it will chain them such that it first gets all the elements from this one, then all the elements from this one, then all the elements from this one, and it behaves as a simple iterator that just has all those elements in sequence. So essentially we want to have all those elements in sequence. We use chain. Chain expects different arguments, so we can unpack this generator that gives us 3 different lists from this slice. We take maximum of that. So there is, of course, many more ways that are perhaps more readable, though for me this is quite readable. But this is a nice example of many constructs that are pretty, I don't know if idiomatic in Python, but still maybe not common in other languages, such as, of course, the slices, the parentheses denoting a generator expression. Those could, of course, also be those square brackets. In that case, we would also create a list, but it would essentially behave the same. And this unpacking, this chain function, if you don't know some of those, then I encourage you to look them up online. And also, by the way, if you, for instance, are familiar with deep learning, if you have your favorite deep learning library or some other tensor or matrix manipulation library, and of course, what we're doing here is simply just a max pool, right? So for instance, for torch, it will be max pool 2D. We have kernel size 3.3 and stride 1.1. So this is one way of thinking about that operation, because this is just taking this max of those 3 by 3 things is just a max pool, and kernel size specifies this size of, in this case, a square. And stride gives us how much we have to skip in both directions whenever we want to generate another number. So if you're not familiar with the pooling operations, or for instance convolutions, because they also operate on kernel sizes and strides, and you're in a way interested in deep learning, or perhaps you're a beginner and you're learning this at this point. So this is, quite a similar concept, and of course you can use this function from your favorite deep learning library to also solve this problem. Though I don't think you can do this on LeetCode, because I don't think that they have Torch available for import.